Hey everyone, welcome back. Today we are going to solve problem number 50, x power n. First, we will see the explanation of the problem statement, then the logic and the code. Now let's dive into the solution. So in this problem, we are given two variables x and n, right? So we need to implement a function x power n, right? So here x is 3 and 3 power 10, that is n. So this particular problem can be solved using order of n. We can multiply the same number 3 10 times. This is one solution. But we can write a more optimal solution by reducing the time complexity by log of n, right? So here we are going to handle the repetitive cases. So here 3 power 10 can be written as 3 power 5 multiplied by 3 power 5, right? So here we are using 3 power 5 two times. So rather than using two times, we are going to use it only one time. This will be done using the recursion, right? We will use the first 3 power 5 to calculate the second 3 power 5. We are not going to repeat the process, right? And we can further reduce 3 power 5 by 3 power 2 and 3 power 2. So here we are taking n by integer division by 2. So we are going to get 2 as the power, right? And here we have 3 power 4, right? This is 3 power 4, but we have 3 power 5 here. So when we have an odd power, we need to multiply the 3, the x itself, once more, right? This will be a constant. So when the power is odd, we need to multiply the x one more time, right? So now we need to consider the base cases for the recursion. So when the power is 0, it is going to be 1, right? So when n is equal to 0, we need to return 1. The next case is when x is 0, we have to return 0 as well, right? When x is 0, we need to return 0. 0 power n is going to be 0 in this particular case. So we need to return 0. And there is also another case. What if my n is negative, right? When we have a negative power, this is nothing but we just need to calculate 3 power 10 and we need to take reciprocal of it. So we will see how we are going to handle this as well in the code. So the time complexity will be log n and space will be constant space, right? So that's how the logic is. Now we will see the code. So before we code, if you guys haven't subscribed to my channel, please like and subscribe. This will motivate me to upload more videos in future. And also check out my previous videos and keep supporting guys. So here we will write a function separately called bs, where we will pass the x and n, and we will take the absolute value of n. So when we return the result finally, we will consider whether n is negative or positive, right? So initially we don't have to care about whether it is negative or positive. We just take absolute value of n. So initially we have to write the two base cases. That is when x is equal to 0, we need to return 0. And if n is equal to 0, we need to return 1, right? So here we are going to have a result variable where we are going to do the recursion on top of x and n. So here we are reducing the n by half by using the integer division by 2, right? So after that, we need to multiply the result twice. So here we are multiplying result twice. This multiplication represents the example that we saw, 3 power 5 into 3 power 5, right? So then we need to check whether n is odd or even. If n is odd, we need to multiply the x one more time to the result, right? We had 3 power 2 and 3 power 2 where we multiply 3 again, right? We need to multiply that extra 3. So the x represents the constant here. Else, if the n is even, we just need to return the result itself, right? So after finding the result, we need to check whether n is negative or positive. If n is positive, we just need to return the result. Else, we need to take a reciprocal of result, right? That's all the code is. Now we will run the code. As you guys see, it's pretty much efficient. Thank you guys for watching this video. Please like, share and subscribe. This will motivate me to upload more videos in future. And also check out my previous videos and keep supporting guys.